All right. Logarithms. You will find out throughout this chapter I will very frequently take your calculator away, because I want you to actually know the information instead of only knowing what the calculator tells you. Because it's very frustrating when the answer to a problem is 2 and you write 50 and 50 has no potential shot of even being close to correct. But it's what the calculator told you. Okay. Really, if you can remember, as it says right here, remember this one example and it will take you a long ways. This one right here is called exponential form. It says 2 to the third is 8. Hopefully you know that to be true. Believe it or not, this is saying the exact same thing, just in a completely different language. It's saying log base 2 of 8 equals 3. That's how it's read. Notice the base over here was 2, and when I said that, I said base 2, right? Log base 2. What you really need to know about logarithms is they basically solve for the exponent. And so what it's saying is, if I just gave you this problem, what you're really trying to find out is 2 to what power would actually give me 8. Now, are those numbers guaranteed to be nice? No, I can make that a bad number quite easy. It's not 5. It's 2 to some power to give me 10. Okay. 2 to the 5th, we just found out it's pretty big, right? That's 32, so that's not right. It's going to be 2 to something a little bit more than 3, right? Okay. And so that's what we really want to work towards, is eventually, what if they're not nice? How do you figure them out? And this whole chapter is dedicated to basically, what if the variable's in the exponent? What do you do? It's not at a level we're used to seeing it. And so we have to get some skills and some strategies to be able to solve that. So this one is just basically saying, write it in logarithmic form. Because these are all in, what was the form? What did I call this again? Exponential form. And so all you have to do is just rewrite it for now. So basically this is translating skills. So what's the base on A? The base is 3. Okay. So the base up here is 3, so the base down here has to be 3. We know that logarithms are supposed to solve for the what? Exponent. So what should be on that side of the equal sign? The 4. The exponent better be there. I kind of call that the leftover spot. All right, and what's left over is 81. What it is really saying, though, so this is done. That's it. You're done. What I want you to be able to translate, though, is it's saying 3 to that power is 81. Okay. And that's really all it's saying. This last one I just recently switched. I just left it. I had it as 2 to the 5th equals 32. Or no, 2 to the 5th equals 25 is what I used to have. And nobody would ever catch it. Because 2 to the 5th is not 25. But they'd write it down anyways. All right? But obviously 5 to the 2nd is 25. So we're going to write this as log base 5 of 25 equals 2. So you see, if you remember, the base goes there, it solves for the exponent. That's really not that hard. The only time it gets hard is what if that exponent is just a really bad number. And that's where the calculators will eventually come in, but not for quite a while. Now this has negative exponents. Do you agree that 4 to the negative 2nd actually is 1/16? Do you agree with that or no? Because maybe I'm tricking you on this one now just to see if you're paying attention. No, because it means that it's unhappy, right? And it will be written that way. So it is 1/16, right? Do you think it changes what you do logarithmic if stuff like this happens? No, if that's true, I should still be able to do it, right? So it's log base 4 of 1/16 is -2. All right, I'm going to take this chance to tell you something. Look at all these numbers inside the logarithm. You see how these are all in the logarithm? They all have one very important thing in common. They're all positive. You better not put a negative number in there. Is it okay to have a negative number over here for an exponent? That's okay. But inside the logarithm, not okay. And we'll explain as you understand logarithms better why it can't be negative. Okay? Are there any questions on switching from exponential to logarithmic? Well, obviously you got to do it the other way then. When translating, you got to be able to work in both directions. And so this is apparently logarithmic form. We're going to change it around and see if it's true. So what's the base on A? 5. Exponent is 3. It better equal. Do we agree with that statement? So in both languages, should that statement be true? Yeah, it is. How about this one? It's saying 8 to the 2/3 equals. Is that statement correct? How do you know? Some said yes, some said no. How do you know? What is it really saying, this side? What does a fraction exponent mean? Yeah, radical, right? There's a 2 and a 3. Where's the 2 go? Inside, outside? Inside. 3 goes outside. So what is 8 squared? What's the cube root of 64? It is actually 4. So it does work out. It is true. And what if they put decimals? That's not negative, is it? Did I say anything about decimals? No, I just said what shouldn't you put in the logarithm? You shouldn't put negative. So this is okay, right? So it's saying 10 to the negative third power equals 0.001. Do you believe that? Or did I throw one in there that's wrong? Well, this means 1 over 10 to the third, right? In other words, 1 over 1,000. How do you read this number? 1,000th. 1,000th, get it? 1,000, 1,000? Yeah, that's true. All right. You always got to watch. You never know. I might throw it in there that's strange. All right. So any questions on switching from one language to another? All right. Here's some important properties of this logarithmic language. These are truly important. This says log base 5 of 5 to the third. Apparently, I can evaluate that. Apparently, it should be a value when I'm done. So the word log just goes away, or how does that work? Well, here's truly what we're looking at. I just want to show you. Let's say this were to equal. I just want to prove something to you. Let's say this was to equal, say, x. And then I'm going to show you the shortcut. But you have to believe me first. Let's rewrite it in exponential form. What's the base over here? 5. And what's the exponent of the entire problem? The exponent, it's that, right? That's what we're solving for. Has to equal what's in here, right? Which is 5 to the third. Didn't we do this already? Didn't we just solve problems like this? When you get a problem like this, what can you do? Yeah, right? So x equals 3. Now let me show you a little bit faster way. When the base of your log and the base of what you're taking to a power are the same, but notice what I said. The base of the log and the base of what you're taking to a power on the inside are the same, cross them off. And do you believe that? Well, this is what it turns into, so it should work. So now, is the base of the log and the base of what I'm taking to a power the same? What's the base of, I'm taking something to a power, right? What am I taking? This is the power, right? And what am I taking? I'm taking 6 to some power, right? That's the base of what I'm taking to a power. Where's my logarithm? It just happens to be in the exponent, right? What is the base of that logarithm? 6. Guess what? Cross them out. 2x plus 5. Done. But that has to happen. Is that always going to happen? Are there times you can make that happen? Yeah, that's the key. There are times you can't, but there are times you can make that happen. So, like right here, are the base and the base of what I'm taking to a power the same? No, but can I make them that way? Yes, I can. So let's rewrite it. Log base 2. Well, how am I going to rewrite 16 so that I can do that little cross-off maneuver? 2 to the close 4th, right? All I did in green was rewrite the problem, but I rewrote it in a way that I could just cross things off, right? So the answer is Okay. So why don't you try that last one real quick on your own? Well, we know it's log base 3, right? So 81. Any suggestions on rewriting that? Beautiful. And realize the answer is not always 4. Okay. Which number of all of these have I really, in these two, which number did I not try and mess with? The base of the log. Don't mess with the base of the log. All right, at least when it's in this form, just leave it alone. Okay. Now, so on the side of your notes somewhere, apparently you're supposed to add on letters E and F. This is example 3, E and F. Either below or off to the side, wherever you have room. All right, letter E. Can I just cross stuff off if it sits right now? No, so now we got to get a little bit more clever. Make it unhappy. Okay, so it's log base 2 because I told you not to mess with that base of the log, right? So we've got to mess with the 32. And what we're going to do is rewrite 1 over 32 as basically 2 to the negative 5th power, right? And 2 to the negative 5th is the exact same thing as 1 over 32. And, well, now, look at that. It's perfect. Well, except for my G. That's not so good. So that crosses up. Done. Okay. So try letter F right now on your own. Log base 5 of 1 over 25. All right, so I told you not to mess with that 5 that was already there, so we're trying to make another 5, basically, if we can, right? That'd be nice. And we can. We make it 5 to the negative 2. All right, example 4. Something different. It says solve. So what must be in these problems somewhere? An x and, or a variable of some kind, and an equal sign. And hey, we have both. Happens to be x squared, but we have both. This is very nice, actually, this problem, because it's saying log of something is a calculation that's done. So this is saying to do some kind of calculation to that. Do you agree that's the exact same calculation over there, but of something else, correct? For these two to work out the same, that calculation we're doing, don't you think this better say 100 when we're done? For this calculation we're doing to work out? And so here's the key. If you have the rules that you were given in Algebra 2 that kind of came from me, the two rules that we're going to talk about later is if everything's in a log and you have only one log on each side, you can just cross them off. You don't even need them anymore. It's kind of like that when the one we just had, right? We didn't need this anymore to help us with the problem, okay? Because we got them to match. Same thing here. It's log base 10 and log base 10. I don't need it. But what if one of them's log base 10 and one's log base 6? Can you just cross them off like that? No, big difference. Right? And so in this problem, x squared plus 36 has to equal 100. Now some of you are thinking quadratic. You could do it that way, and those could show up. But you don't have to in this one because there's no linear term. There's no like 5x or 2x or anything like that. And so the easiest way to do this is get the variable by itself. C4. Very good. Positive or negative 8, because we were the ones that decided to take the square root throughout this problem. We didn't have to. But when dealing with logarithms, you better make sure you're not going to try and take the log of a negative. So we better check these answers. If I plug a positive 8 right back in here, does that actually make it say 100 like it's supposed to? Yeah, so am I trying to take the log of a negative? No. How about negative 8? Can I substitute negative 8 in there and does it say 100? So am I trying to take the log of a negative for either one of these? Just because the answer is negative doesn't mean that you're trying to take the log of a negative. So actually both of those do work. Okay? And I might come back to that one in a second just to show you something, but we'll see. All right. There's two ways of doing this one. I'll show you the easiest one for now, and we'll work on the harder one later, because you're going to need the harder one later. This is what form again? We have two forms, right? Two languages. Which language is this in? Logarithmic. What's the other language again? Well, if logarithmic's not helping, maybe we should try, because there's no log base 7 over here, right? So I can't just cross it off. That'd be great if I could. We'd almost be done, right? Y would be negative 2. But there is no log base 7 there, so that's a problem. So let's rewrite it in exponential. Let's change the language. 7 to the negative 2 equals y. So did that help? Changing the language made this a much easier problem, didn't it? Okay. And so I would like you to fix it, though. We have to make it happy. And so it's 1 over 49. So the two types here are if they're the same log on both sides, just cross it off. It doesn't have any bearing on the problem. If logarithmic isn't helping, well, change the language. So which one's going to work here? Do I have the same log on both sides? No. So right now, logarithmics, can I make this side like cross off, kind of like we did earlier? It's a b as a base, right? So you can't really make this one cross off like we did earlier. Well, we better go to the exponential then. So the base is b to the third equals, have we turned it into something we can do? Yeah, all we did was translate. And how do you solve something like this? Well, take the third root, house 5, b is, that's a little bit harder, third root of 64. Is it positive and negative 4 or just 4? Just 4, very good, it's a third root. And again, you should probably check, does putting 4 in there cause any problems? Is it negative? No. Right? And imagine that. 4 to the third is actually 64. No way. Whoa. There's a lot of stuff going on over there. There's an x, a fourth root of 12, and 1/8. Yeah, good luck with guess and check on that one. You could do it, but it would be a lot of work. So can we cross off both logs like we did in example 4a? No, not really, can we? So we better change the language. What's the base? To the equals, yeah, the fourth root of 12, right? Here's what I noticed in this problem, and maybe you're looking at something slightly different than I am, but it's like this is almost two different languages as well. The one on the left has a fraction in the exponent. The one on the right is a radical. And isn't that what a fraction exponent means anyways, is a radical? So either we should both get these to radical, or both get them to fractions in the exponent, so that it's the same language. Does it really matter which way you go? No. So would you rather get it so that they're both fractions in the exponent or both radicals? You tell me. Fractions in the exponent? Let's do it. So x to the 1/8 equals, what number is really here? Yeah, 1. So at least they look the same now, right? I'm kind of glad you chose this way because this should help you in the long run. Now what do? I got to get x by itself. It's not. I got a 1/8 power there. How do you get rid of a 1/8 power? Well, remember, truly what it means is that, correct? You know how to get rid of that. How would you get rid of that? Take it to the 8th power, right? So let's take this side to the 8th power, that side to the... Do you see how it actually does get rid of this? Because what do you do when it's a power to a power? Let's play, what's 1/8 times 8? Nope, close. 1, right? So this says x to the... And isn't that what I want it to say? Okay, so you see how that works? That's why I'm glad you guys chose to go this way. Equals. So here's your base, 12. What am I supposed to do here? Multiply. Well, what's 1/4 times 8? 2. Well, that got a whole lot easier in a hurry. X equals? And once again, you should check, and it doesn't cause any problems, so we're good. Yes? Okay, good question. I was hoping somebody would ask that too. It was, what would it look like if you did it the other way? We'll keep both forms up here so you can see them both. So where did we make that choice? Right here, right? Everybody agree? So you would change this one to that. Now they at least have radicals. Okay? And you would turn around, and you already told me how to take care of this, right? Cancels. Now this is where the part I was concerned about that it might get tricky. Okay? You take the 4th root of something to the 8th power. That gets kind of tricky, and that's where you might try and go into that other direction. This one would go on top, that would go on the bottom, right? That's how you would rewrite it. And then you can see the 12 to the 2nd power again. Okay. And so, I mean, I could show you another way here, but that gets kind of goofy. So it is still 12 squared, or 144. What's that? Right. The only problem is when they don't come out evenly, that it gets tricky. And you have to divide the power you're taking this to, kind of like this one here divided by that root. The root always goes on the bottom. The 4th root, 5th root, 6th root, that number would always go on the bottom of that fraction. But if you were to say have a 6 here and a 4 there, that's when it gets kind of, yeah, goofy. Okay? So it ends up still as a radical. They don't always come out nice. So we talked about a lot today. How do you feel about it? Pretty good? Yeah, that's bad. All right. So you're starting to see, I know some of you don't remember Chapter 5 from Algebra 2, but you're really starting to see it. It's all over this particular topic.